Welcome to Lesson 1-2, Adding and Subtracting Decimals. Today we're going to talk about how to find the decimal sums, decimal differences, to use the associative property of addition, the commutative property of addition, and the identity property of addition. Alright, so to start out, we're not going to start with vocabulary. When we move to our properties, you will have to go back to your vocabulary page. However, right now, we're going to talk about how to add decimals. Right, so there's 4 easy steps to adding and subtracting decimals. The first step is always to line up your decimals. Right, so what this means is, if I have a decimal point, I need to have all of my decimal points line up, and then I have to have all my whole numbers line up and all of my decimals line up. One thing that helped me in the past was if I have 1, 2, 3, 4 numbers, then I put in 1, 2, 3, 4 decimals, and then I build my number around my decimals. So in this case, 9 and 7/10. So it'll be 9 and 7/10, 9 and 7/10. So you build around that decimal, so it makes it a little bit easier when we're learning to or when we're beginning to line up our decimals. Right, the next step that we have is to fill in the empty spaces with zeros. So you'll notice right here, we have a 5 in this column, but we have nothing else. We can add zeros here, and it does not change the value of the number. Now, if we did this on the left side of the decimal, it would change the value because this would change from 9 to 90. And this changes only from 7/10 to 70 hundredths, and these two things are what we call equivalent. Okay, so 7/10 is equal to 7 hundredths, or I'm sorry, 70 hundredths. So that way we are able to add those zeros and not change the value. The third step is to add or subtract. Now, you decide whether or not to add or subtract by looking at the problem. This problem in particular tells us to add. So we add our numbers just as we normally would, and then that final step is to bring the decimal straight down. Right, so since our decimals are all lined up, we just bring that decimal straight down. So let's go ahead and try a couple of these. So if I have 1 and 8/10 plus 0 and 2/10, I know that I have 2 decimals, so I'm going to line up my decimals and then build my numbers around. I know 1 is on the left side of the decimal and 8 is on the right. For this one, I know 0 is on the left and 2 is on the right. I know that I'm adding, so I add. I get 8 plus 2 is 10. Carry the 1. 1 plus 1 is 2. And then I know I have to bring that decimal straight down. So my answer in this case would be 2 and 0/10. So what I would like you to do is I would like you to give these problems a try. You're going to pause the video, try all 5 of the problems, and when you come back, we'll check over your answers. All right, so over here we have 4 minus 7/10. This is where students get a little bit tripped up because of the fact that there is no decimal here. So think of this, whenever you see a whole number without a decimal, think of it as money. So you wouldn't do this to show me that you have $4 because that actually wouldn't be $4. You would show me this. You would say, I have 4 and then a decimal and then your zeros. Right, so here we put the decimal on the right side of the 4, and then we add a 0, and then we have to do 0 minus 7, but we can't, so we have to borrow from the 4. It becomes a 3. The 0 becomes a 10. 10 minus 7 is 3. 3 minus 0 is 3. Bring down the decimal. Your answer is 3 and 3/10. Okay, so we had to do the same thing over here. We had 8 and 5/10 minus 7 and 29 hundredths. So we line up the decimals, line up our whole numbers, And then we added the 0 here to make this number as long as this number. Then what we had to do is we had to borrow from the 5, make the 0 a 10, 10 minus 9 is 1, 4 minus 2 is 2, 8 minus 7 is 1. Bring the decimal straight down. I'll give you an opportunity to look over these, so go ahead and pause, check your answers. If yours do not match mine, make sure to check your work and make sure that it matches what we've done here. All right, so now we're getting into the properties of addition. The associative property of addition works like this. So what does 0 and 1/10 plus 0 and 9/10 plus 0 plus 5/10 give us? Well, because we're using the order of operations, we know that we have to do what's in the parentheses first. Okay, so when we do this, you would have found that we got 1 and 5/10. Now, if we move the parentheses and we do 0 and 1/10 plus 0 and 9/10 first, so in this case we found that this gave us 1 and 4/10, and then we added that 1/10 to it and got the 1 and 5/10. In this case, I know that 1/10 plus 9/10 has to give me 1, and then I'm going to add that to 5/10, which gives me 1 and 5/10. Okay, so we can conclude from this that the associative property of addition has to do with moving our parentheses. The important part is, though, you can only do this when you're using addition. The associative property of addition. So you can only move the parentheses because we're working with addition. We'll have properties later on that we'll talk about that we use with multiplication, but in this case, if we add subtraction, this would not work. It does not give us the same answer. So the associative property tells us that changing the grouping of the add-ins does not change the sum. So again, go to your vocabulary, fill this out. Okay, so what this means is if I do 3 plus the quantity 4 plus 5, it's the same thing as doing the quantity 3 plus 4 plus 5. Any way you add this up, it's going to give you the same answer. And make sure when you're using this vocabulary that you go back and check what it means before using it as an answer. All right, so the reason we move parentheses is to make the problem easier for us to do in our heads. So when we want to make problems easier to do in our heads, it's nice to work with numbers that are ending in 0. So like our tens, hundreds, all those numbers. So we like to find with decimals a number or decimals that will add to 1. So in this case, if I had to do 3/10 plus 1 and 2/10 first, it wouldn't make it that easy. Okay, but if I move the parentheses over here to these two decimals, 7/10 plus 3/10 is going to give me 1, because I know 3 plus 7 gives me 10, so I have to carry that 1 to the other side. Okay, so why does moving the parentheses make it easier to do in my head? Because I immediately know that this gives me 1, and then I know that 1 plus this number is just going to be 2 and 2/10. The commutative property of addition. So what does 4/10 plus 6/10 equal? Well, 6 and 4, we know that gives us 10. Carry the 1, gives us 1/10. Now, what about 6/10 plus 4/10? Well, again, it's 4 plus 6, which gives us 10. Carry the 1, it gives us 1. What does 6/10 minus 4/10 give us? In this case, it's going to give us 2/10. And then 4/10 minus 6/10. Do not tell me that it's going to give us 0 and 2/10, because it does not. It gives me a negative 0 and 2/10. These two numbers are not equal. This is a negative and this is a positive. Right? So, based on this, what do you think the commutative property tells us? If you guess that the commutative property tells us that changing the order of the addends does not change the sum, then you are correct. What this means is if I'm adding numbers together, I can rearrange them in any order and still get the same answer. So 7 plus 9 is going to be equal to 9 plus 7. No matter which way I do this problem, it's going to give me the same answer. Now I know this is difficult because they seem similar. However, the associative property, so think of the word associate. So the associative property talks about numbers and groupings that associate with each other. So the 3 and the 4 are associating with each other first, whereas here the 4 and the 5 are. This changes in the associative property who the numbers are grouping with or associating with. The commutative property, okay, we have the word commute, which means to move. The commutative property tells us we can move our numbers around. So what I want you to do here is I want you to think of what we talked about with adding numbers together. We always want to find numbers that add to 10. In this case, when we're finding decimals that add to 10, so we said like 0 and 3/10 plus 0 and 7/10. Okay, 7 and 3 get us to 10, but since we're working with decimals here, it actually gets us to 1. So I want you to look at these 4 numbers, and I want you to rearrange them in your notes. Okay, so you have space to do that. Right here, I want you to rearrange them in the notes to make them easier to do in your head. When we come back, we'll go over your answer. Alright, so you should have rearranged it somehow to have the 1 and 2/10 and the 8/10 together, and the 4/10 and the 1 and 6/10 together. Okay, you can have this in any order as long as these two numbers are together and these two numbers are together. So you could have this, you could have it like this, you could have these numbers first and these numbers for second. It doesn't matter as long as you paired these two numbers together and these two numbers together. Right. So I want you to think about why this made it easier to do in your head. If you are telling me because you take the 6 and the 4 and you get 10, so you carry the 1, so this just becomes 2. And then if you take the 8 plus the 2, you get 10, carry the 1, then this becomes 2. Now your problem becomes 2 plus 2. So instead of having to list all these out and then add them together, you can add these together in your head knowing that 4 more tenths added to this would get you to 2, and 8 more tenths added to this would get you to 2. And we all know that 2 plus 2 gives us 4. So moving our numbers around to make a tens number or a hundreds number always makes adding much more easy for us to do. Okay, and again, this is the commutative property. It allows us to move our numbers all over the place when we're adding. What number is the only number that you can add to any other number and get that exact same number for an answer? So if I gave you the problem 2 plus something equals 2, what's the only number we can put here? If you said 0, you are correct. Okay, so this is what we call the identity property of addition. The sum of any number and 0 is that number. So the identity property of addition tells us that if we're adding zeros to something, that number gets to keep its own identity. So if we take 40 plus 0, it gets to remain a 40. If we take 2 plus 0, it gets to stay as a 2. Okay? And 0 is the only number that allows us to do that when we're working with addition. Okay, so what I'd like you to do now is I'd like you to solve this problem in your notes and then post your answer to Edmodo. You'll notice here that the problem states that Joey is balancing his checkbook for the month. He started with $567.89 and had the following purchases and payments. A credit means you get money, so it's added to your bank account. A debit means you lost money, so it is subtracted from your bank account. So what I want you to try and find is how much money, or what would the balance be in his checking account after all of this occurs. Okay, so this is what he started with. You need to find the balance. Show all of your work in your notes, and all you have to do is post your answer to Edmodo. As always, if you have any questions, be sure to post them to Edmodo so we can go over them in class tomorrow.